Hello everyone, I am Dr. P. Kumari, working as Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. So here in this video, today we are going to learn about linear differential equations. So what are the problems we are having in linear differential equations? How we can solve these linear differential equations? We are going to see in this video. So first of all, how to solve the linear differential equation with constant coefficients. So here the equation form of the linear differential equation is f of d into y equal to f of x, or in place of f of x we are having q of x also, f of t into y equal to q of x. So here if you are having the equation form like this, so we are having the complete solution here. What is the complete solution? Complete solution or general solution is y equal to CF plus PI. What is the meaning of CF is? CF is complementary function and PI is particular integral. So this is the general solution of the given equation. So if it is having the form f of d into y equal to q of x. For example, if you are having f of x equal to 0 or q of x equal to 0, then what is the equation form we are having? F of d into y equal to 0. So this is the homogeneous equation. Homogeneous equation. We are having like this. This is non-homogeneous equation. So for the non-homogeneous equation, general solution is y equal to CF plus PI. It's a complementary function plus particular integral. So here for the homogeneous equation, complete solution is CF only. So CF is nothing but complementary function. So here the solution of the homogeneous equation is only complementary function. The solution of the non-homogeneous equation is complementary function with particular integral. So these are the important points you should know before going to solve the problems. So here we can observe the problem. See this, solve the differential equation. So what is the differential equation they given? D square y by dx square minus 8 into dy by dx plus 15 into y is equal to 0. This is the given equation. So from this equation we are going to write the general form. So already we know, we discussed in the previous videos, d is the operator, so that is nothing but d by dx. If you are having d square, so that is d square by dx square. We are having d cube by dx cube, we can replace here, that is d cube. So here nothing but in place of d square by dx square, we can replace the capital D square. So d square y minus 8 into dy plus 15 into y is equal to 0. So from this I can write the d form, f of d form, that is d square minus 8d plus 15 into y is equal to 0. So before that, here we are having the equal to 0, that is nothing but f of d into y equal to 0. This is a homogeneous equation form. This is homogeneous equation form. So for the homogeneous equation, what is the complete solution or general solution? That is y equal to only complementary function. So complementary function is the general solution of the homogeneous equation, nothing but. So here for this equation, so finding the complementary function is enough. So for this we can observe here. So this is the f of d square minus 8d plus 15 into y equal to 0. So from this, what we have to write? First we have to write the auxiliary equation. What is the auxiliary equation? F of m equal to 0. So what is the need of the auxiliary equation? To find out the complementary function, we need the auxiliary equation. From that only we can calculate the complementary function. So first, what are the steps we have to follow? First we have to write auxiliary equation. What is auxiliary equation? F of m equal to 0. What is the second step? We are going to find the roots of the given equation. So next, what is the third step? Third step is depends on the nature of the roots. depends on the nature of the roots. We have to write the complementary function. So these are the three steps we are going to follow here to find out the solution of the given homogeneous equation. So according to this procedure, first we are writing the auxiliary equation. F of m equal to 0 means in place of f of t. So nothing but in place of t we have to replace the f of m, I mean m value. So d square minus 8d plus 15. Now f of m is equal to 0. So what is this? M square minus 8m plus 15 is equal to 0. So from this we are going to find the roots. So here we are having the factors here. 3 5s are 15. I can write this one as m square minus 5m minus 3m plus 15 equal to 0. So now I am taking the m common here, m minus 5 minus 3 common here, m minus 5 equal to 0. So m minus 3 into m minus 5 is equal to 0. So m value is 3 comma 5. So here we got the roots 3 comma 5. Here the two roots are real values and distinct. That means different. Distinct means different. So based on this nature, we can find out the complementary function. What is the complementary function? C1 e power m1x plus C2 e power m2x. What are these m1, m2? From this we can write m1 equal to 3, m2 equal to 5. Otherwise, you can take m1 equal to 5, m2 equal to 3. So, there is no issue for this. So, first value only m1, second value only m2, not like that. So, we can write the complementary function equal to C1 e power 3x plus C2 e power 5x. This is the complementary function. So, what is the solution of the given homogeneous equation? Only complementary function is the given equation. So, y equal to C1 e power 3x plus C2 e power 5x. This is our general solution or complete solution of the given equation. Is it clear? Same thing we can observe here. M square minus 8m plus 15 equal to 0. From this, we are calculating the roots 3 comma 5. So, based on these roots, what is the complementary function? C1 e power 3x plus C2 e power 5x. So, finally, this is the homogeneous equation. So, homogeneous equation solution is only complementary function. So, finally, y equal to C1 e power 3x plus C2 5x. We are moving with one more example here. Observe, solve the differential equation. What is that? D cube y by dx cube and minus 6 d square y by dx square plus 11 into dy by dx minus 6y equal to 0. So now, first we are writing the operator form here. So what is our operator? First d is d by dx and d square is d square by dx square. And d cube is nothing but d cube by dx cube. Based on this, we are writing the operator form. This is d cube y minus 6d square y plus 11 into dy minus 6y equal to 0. Now we are writing this one d cube minus 6d square plus 11d minus 6 into y equal to 0. That is only we got here. This is nothing but f of t form. So, f of d into y equal to 0. F of t into y equal to 0. This is the homogeneous equation. For this homogeneous equation, what is the solution? Then the solution equal to only complementary function. Then the solution equal to only complementary function. That means we have to calculate the complementary function. That is enough for the solution. So, for that, what we are going to do here? First, we have to write the auxiliary equation. What is the auxiliary equation? F of m is equal to 0. So, from this we can write f of m value. So, in place of d. So, in place of d we are replacing m here. So, m cube minus 6m square plus 11m minus 6 equal to 0. So, now we are going to calculate the m value here. Here m cube is there and m square is there. From these two values, I am taking the common m square. So, what I am getting here? M minus 2. and from these two I am taking the common 4m. So again I am getting m minus 2. From these two values, I am taking the 3 common. I am getting m minus 2. In these 3 terms, I am having m minus 2 common. Take it out. So m minus 2. So here m squared minus 4m plus 3 equal to 0. So I can have the roots here. Otherwise you can calculate the roots by using this method also. So here m cube quotient is 1 and m square quotient is 6 minus 6. M quotient is 11 and constant is minus 6. Here first we are taking 1. So here random check we have to do. So for this first value we are getting the root or not, we will calculate. Otherwise we will move for minus 1, 2, minus 2 like that. So first I am considering 1. So here the first value we have to take it as 0. So now do the addition. 1 plus 0 is 1. So 1 ones are 1 here. So minus 6 plus 1 is minus 5. So 1 into minus 5 is minus 5. So 11 minus 5 is here 6. 1 6 are 6. Here minus 6 plus 6 is 0. So from this I can write m minus 1. Here this is a root. So m minus 1 into here m square quotient. So m square minus 5m plus 6 equal to 0. So now already I am having m minus 1. So for this I am writing the roots here. So m square. 2 3s are 6, right? So minus 2m minus 3m I can write plus 6 equal to 0. So m minus 1 as it is. And here I am taking the m common. So m minus 2 is there. And here minus 3 common. So m minus 2 is there. So finally m minus 1 into m minus 2 into m minus 3 is equal to 0. So from this m values are, that means roots are 1 comma 2 comma 3. So by using this method also you can calculate. Otherwise you can take common terms and from that also we can get the roots here. So here m square minus 4m plus 3. So 1 3s are 3. I can write here. For this one, what are the roots I am writing here? So 1 3s are 3. So m square minus 3m minus m. Here minus 4 we have to get, right? So minus 3 minus 1 is a minus 4. So plus 3 equal to 0. So from this I am taking the m common. So m minus 3. Here minus 1 common. So m minus 3 equal to 0. So this one is minus 1 m minus 1 into m minus 3 equal to 0. Already we are having m minus 2. So in this way also we are getting the same roots, m equal to 1 to 3. Here also m equal to 1 to 3. So we can calculate the roots by using this method also. Otherwise by using this method also. Any method you can use to get the roots here. So in these two methods we are getting the m value is 1 comma 2 comma 3. So now these three values are real and distinct and different values. So m1 is 1, m2 is 2 and m3 is 3. So based on this nature of the roots, I can write the complementary function. Complementary function equal to c1 e power x. That means m1x. First I will write the form. After that I will replace the values. C1 e power m1 m1x, C2 e power m2x plus C3 e power m3x. Now I am replacing the values here. C1 e power x plus C2 e power 2x plus C3 e power 3x. So this is the complementary function. Only complementary function is nothing but our general solution for the homogeneous equation. So that's why I am writing y equal to C1 e power x plus C2 e power 2x plus C3 e power 3x. So this is our general solution of the given equation. That is only we wrote here, we can observe. So you can observe here, this is the complementary function. So e power x plus C2 into e power 2x plus C3 into e power 3x. So for the homogeneous equation, only complementary function is the general solution. So based on this, y equal to C1 e power x plus C2 into e power 2x plus C3 into e power 3x. This is the solution of the given equation. This is the way to calculate the solution of the homogeneous equation. With one more example here. Solve. So here the given operator from directly. So d power 4 minus 10 into d cube plus 35 d square minus 50 into d and plus 24 equal to 0. So here they give an f of t value. What is the f of t? F of t equal to d power 4 minus 10 into d cube plus 35 d square minus 50 into d. Now, what is the f of t they given here? D power 4 minus 10 into d cube plus 35 d square plus 50 into d plus 24. So, based on this, here before we calculated two values, for the d square, we are getting the roots, two roots, m1 comma m2. We having d cube, we are getting the roots here, three roots, m1 comma m2 comma m3. Like this here we are having the power is, highest power is d power 4. So if you are having highest power d square means we are getting two roots, highest power d3 d power d cube, then we are getting three roots, here highest power d power 4. So we are going to get the four roots here. So based on the order, we are going to get the roots. Based on that, we can decide. So here f of t equal to t power 4 minus 10 d cube plus 35 d square minus 50d plus 24. So now, so what is the solution I can write here? The first solution is auxiliary. First we have to write the auxiliary equation. What is the auxiliary equation? In place of t, I have to replace that is f of m equal to 0. So what is the f of m here? M power 4 minus 10 m cube plus 35 m square 50m plus 24 equal to 0. So already I discussed about this procedure, how to solve this equation, otherwise how to get the roots in the previous problem. How we calculated, we can use the method of the two methods to calculate these roots. So observe here. So this one we are writing m power 4. So I am writing this 10 m cube as a 1 m cube and minus m cube. And here for 35 m square I am writing as a 9 m square plus 26 m square. So for the 50 I am splitting as 24 and 26 and plus 24 equal to 0. Now from these two I can take the common m cube. So m minus 1 is there. So from this I can take m 9m square common. So here m is there. So m minus 1. Here I can take the common 26m. So 26m here. So m minus 1. From these two, I can take the common 24. So minus 24 into m minus 1. Then all these terms, I am having the common m minus 1. So m minus 1 into here m cube minus m square. That means 9m square plus 26m minus 24 equal to 0. So otherwise, we can take the quotients of m4 quotient is 1 and m cube quotient is minus 10 and m square quotient is 35 and m quotient is 50 and constant is 24. So first I am taking the 1 here. So 0. 1 plus 0 is 1. 1 ones are 1. So minus 10 plus 1 is minus 9. 1 into minus 9 is minus 9. So here 35 minus 9. 35 minus 9 means how much we are getting here? 35 minus 9 is 26 and 9 is 35. So I can write this one is 26. So here 126 are 26. So 50 minus 26. How much we are getting here? 50 minus 26. So 10 minus 6 is 4. Here 4 minus 2 is 4. So 24. So already highest value having minus. So minus 24. So now 1 into minus 24 is minus 24. This is 0. So m minus 1. M minus 1. So next value also I can calculate here. Next value also I can calculate here. So what is the next value I am going to take here? So we can observe. So here for the m minus 1, I will try here 2. Already m completed. So here, sorry, already one completed. So that's why I'm trying 2 here. So 0. Here, how to select the values? That is random checking only. We are not having any fixed values here. So we need to check 1 minus 1, 2 minus 2, 3 minus 3. Like that we have to check the random values. Here, first I'm considering 2 here. So 1 plus 0 is 1. 2 ones are 2. So minus 9 plus 2 is minus 7. So 2 sevens are 14. So minus is 6. So minus 14. 26 minus 14 is how much? 26 minus 14. So 6 minus 4 is 2. Here 2 minus 1 is 2. So this is the 12. So here plus 12. Here highest value is having plus. So plus 2 12s are 24. This is 0. So that means here I am getting m minus 2 into m square minus 7m plus 12 is equal to 0. This is the equation we got here. So from this we can calculate the roots here. 3 4s are 12, right? So based on that I am writing the factors here. M square minus 3m minus 4m plus 12 is equal to 0. So here I am taking the m common. So m minus 3 minus 4 common. So m minus 3 equal to 0. So m minus 3 into m minus 4 is equal to 0. So already I having m minus 1 into m minus 2 and one more two values m minus 3 into m minus 4. In this method also when you are taking simplifying this value, here we are getting m minus 1 into m minus 3 into m minus 4 into m minus 2. Here also we are getting the value m equal to 1 to 3. By using this method also we are getting the values here m minus 1, m minus 2, m minus 3 and m minus 4. Nothing but m roots are 1, comma 2, comma 3, comma 4. So that means we can use this method. I mean we can simplify the equation to get the roots also. Otherwise we can use this saba method also to get the value here. So now I am getting the roots here. m1 equal to 1, m2 equal to 2, m3 equal to 4 and m4 equal to 3. So otherwise here 3, here 4, whatever it may be. So we can take m3 equal to 3, m4 equal to 4. So already I told you if we are having the highest power is 2, we are getting the 2 roots m1 comma m2. If we are having highest power is 3, we are getting the 3 roots m1 comma m2 comma m3. And we are getting the highest power 4. So then we are going to get 4 roots here. So based on our power, we got the 4 roots. So these are the roots. So what is the complementary function? Here, based on the nature of the roots, we are going to decide about the complementary function. What is the complementary function? C1 e power m1x plus C2 e power m2x plus C3 e power m3x plus C4 e power m4x. So what is the m1 value? C1 e power x plus C2 e power 2x plus C3 e power 3x plus C4 e power 4x. So this is our complementary function. So here this is the equation form is f of t into y equal to 0. Nothing but this is the homogeneous equation. If it is homogeneous equation, what is the complete solution? So only complementary function is the complete solution. Nothing but here y equal to C1 e power x plus C2 e power 2x plus C3 e power 3x plus C4 e power 4x. So this is our final solution or general solution or complete solution of the given equation. That is only we can observe here. See this. So this is our complementary function C1 e power x plus C2 e power 2x plus C3 e power 3x and C4 e power 4x. So here f of x equal to 0 means this is the only complementary function is the solution. So y equal to C1 e power x plus C2 e power 2x, C3 e power 3x and C4 e power 4x. This is our final solution or general solution of the given equation. I hope we get the clarity about these homogeneous equations. So we are moving with one more example here. So here we can observe the question. Solve y double dash 6y dash plus 9y equal to 0. Here, what is the difference between previous problem and this problem? Here, they given the conditions also. So here, first difference is, here we are having double derivative. I mean, y double dash means nothing but this is the d square. Y dash means this is nothing but d. So based on this, we are going to write f of d form here. And what is the extra values we are having in the question? We are having y of 0 equal to -4 and y dash of 0 equal to 14. These two conditions we are having extra compared to previous two problems. So how to solve this by using these conditions? What is the use of the conditions? We are going to see here. First write down the given equation. What is the given equation? Y double dash plus 6y dash plus 9y equal to 0. Just now I told you y double dash means d square. So we can write d square y plus 6 into dy plus 9 into y is equal to 0. So from this we are writing the operator. So 6 d square 60 plus 9 into y is equal to 0. So this is the f of d value. So here in the RHS part we are having 0, nothing but this is the homogeneous equation. For the homogeneous equation, what is the solution? Y equal to only CF. So finding CF is enough to get the solution here. So to find out the complementary function, what we need first, we have to write the auxiliary equation. What is the auxiliary equation? F of m equal to 0. So from this we are writing the m square plus 6m plus 9 is equal to 0. So here from this we are writing m square plus here 3 3s are 9. So from this I am writing 3m plus 3m plus 9 equal to 0. I am taking the m common here. So m plus 3 here, taking on 3 value common. So here this is m plus 3 again. So equal to 0. So this is m plus 3 into m plus 3 equal to 0. So m equal to minus 3 comma minus 3. That is only we are writing here. M values are here minus 3 comma minus 3. So now, so these two values are same and real. So what is the complementary function? So these two values are here. I am getting m1 equal to minus 3, m2 equal to minus 3. These two values are real and same. So based on this, I am writing complementary function. So complementary function is C1 plus C2 into x into e power minus 3x. This is our complementary function. From this, so only complementary function is the complete solution here, right? So from this I can write y equal to C1 plus C2x into e power minus 3x. So up to this solution is as it is, okay, previous problem. But here they given the conditions y of 0 equal to minus 4 and y dash of 0 equal to 14. These two conditions we are having. So what is the use of these conditions? So from these conditions we are going to get the C1 and C2 values. So after then we can replace C1 and C2 in this solution to get the final value of the y. That is the simplification we are going to see here. So this is the solution of the given equation. So how first I am using the first condition, y of 0 equal to minus 4. That means y in place of x I can replace the 0. So y is minus 14. So minus 4 equal to C1 into e power minus 3 into x value is 0 plus C2 into x into e power minus 3 into 0. So finally here C1 e power 0 is 1 plus here this is 0. So from this I can write C1 is minus 4. C1 is minus 4. That is only we are seeing here. From the first condition we got here C1 is minus 4. Now what is the second condition? Y dash of 0 equal to 14. So from this, I am going to write y dash of 0 equal to 14 means here y dash means I have to do the one-time derivative for the y equal to c1 e power minus 3x plus c2 into x into e power minus 3x. I need the y dash value first. So that's why I am doing the differentiation here. Y dash equal to c1 into e power x is e power x, right? So e power minus 3x is minus 3x. For the minus 3x, so minus 3 into x value is 1 plus here c2 is the constant, here u into v form is there. So u derivative of v is e power minus 3 into x into minus 3 plus v into e power minus 3x into derivative of u is x is 1. So from this I am getting the value y dash equal to minus 3 into c1 e power minus 3x. Here minus 3 into c2 x into e power minus 3x plus c2 into e power minus 3x. Now based on the second condition, so y dash of 0 equal to 14. So here in place of x I have to replace. So and y dash value is 14. So 14 equal to minus 3 into c1 value is minus 4. Otherwise, first simplify this, after that we can replace the c1 value. So minus 3c1 e power minus 3 into 0 minus 3c2, here x value is 0 means this all term is 0 plus c2 into e power minus 3 into 0. So from this what I am getting minus 3c1 e power 0 is 1. Here this total term is 0 plus c2 into e power 0 is 1. So this is equal to 14. So from this I can write c2 equal to 14 plus 3c1. 14 plus 3c1. So that value I am going to substitute here 14. So 3 into minus 4 is 12 minus 12. So c2 value is 2. So this is only we got here c2 value is 2. So c1 value we got from the first condition, c2 value we got from the second condition. So now we are going to replace these two values in the complementary function. So now y equal to c1 e power minus 3x plus c2 into x into e power minus 3x. Now what is the c1 value? Minus 4. So minus 4 into e power minus 3x plus c2 into, here what is the c2 value? c2 value is 2. So 2 into x into e power minus 3x. So this is only our complementary function or complete solution of the given equation. So this is the difference between the previous problems and these problems. So actually for the equation only c1 plus c2 x into e power minus 3x is enough for the solution. But if they given the conditions, we have to substitute those conditions to get the c1 and c2, that means arbitrary constant values, and after then we can replace here to get the solution. This is the way to solve if they given the conditions here for the homogeneous equation. I hope you get the clarity about the homogeneous equations and if they given conditions, how to solve the problems also. Now I am moving with one more example with the homogeneous equation. We can observe the equation here. Solve y double dash minus 4y dash plus 3y. Here in place of ux we are having 4 into e power 3x. So here the given conditions also y of 0 equal to minus 1 and y dash of 0 equal to 3. So as it is procedure we can follow for the non-homogeneous equation also. For the non-homogeneous equation, what is the complete solution? Y equal to complementary function plus particular integral. So that means we have to calculate complementary function and particular integral both. So first of all, we are going to calculate the complementary function. You can see here given equation is y double dash minus 4y dash plus 3y equal to 4 into e power 3x. First we are writing the operator form d square y minus 4 into dy plus 3 into y. So this is the operator form is equal to 4 into e power 3x. So for the complementary function we need only f of d value. What is f of d value? D square minus 4d plus 3. So what is the auxiliary equation we are going to write here, that is f of m equal to 0. So from this we can calculate the roots here. F of m equal to 0 means m square minus 4m plus 3 equal to 0. So from this we can calculate the roots here by using the factorization method. So m square. Here 1 3s are 3. So m square minus 3m minus m plus 3 is equal to 0. Here from these two values I am taking them common. So m minus 3. Here I am taking minus 1 common. So minus 1 into m minus 3 equal to 0. So from this I am getting m minus 1 into m minus 3 equal to 0. So finally what are the m values? m1 equal to 1, m2 equal to 3. Here these two values are real and distinct, that means different. So what is the complementary function? Complementary function is c1 e power m1x plus c2 e power m2x. So what is the m1 value? m1 value is 3, otherwise 1 also. m2 value is 3 or 1 also. So we can take this one as 1 or this one as 2, otherwise you can take this one as 2 and this one as 1. So finally complementary function is c1 e power 3x plus c2 e power x. That means first part is completed. So we are going to find the next second part, particular integral. So what is the particular integral? So what is the formula to calculate that? So particular integral equal to 1 by f of t into q of x. What is the q of x value? 1 by f of t is d square minus 4d plus 3 into q of x value is e power 3x into 4. So this is the constant taking out. So here 4 is the constant, 1 by d square minus 4d plus 3 into e power 3x. So if you are having the e power ax form, we can follow the method 1 procedure. So what is the procedure for method 1? We can replace d equal to a value. So that is only we are going to see here. So what is the d equal to a value? A value is 3. So that means in place of d, we are going to replace the d value here. So here y 4 into, I can write the operator form is d minus 1 into d minus 3 into e power 3x. So here 4 into 1 by, in place of d I am substituting 3. So 3 minus 1. When I am substituting here, we are going to get f of a value is 0. If f of a value is not equal to 0, then up to this is enough. If f of a equal to 0, we are going to get the formula, that is x power k by k factorial. So that is only we are going to see here. So d minus 3 as it is we are writing. So here e power 3x. Here 4 by 3 minus 2 is 2. And this is the pi of a form. So for this we are writing x power here 1 by d minus 3. So d minus 3 power k here. Nothing but here k value is 1. So here k value is 1, e power 3x. So 4 by 2 is 2. Here k value is 1 means x power 1 by 1 factorial e power 3x. So finally 2 into x into e power 3x. This is the value of particular integral. This is only we are observing here. So yp value is 2x e power 3x. Already we calculated yc value. Actually the yc value is c1 e power 3x plus c2 e power x. And we got the yp value also. What is the general solution or complete solution? That is yc plus yp. This is the general solution of the non-homogeneous equation. For the homogeneous equation only yc is enough. But the non-homogeneous equation, we need to get the two values, complementary function and particular integral. So complementary function already calculated, that is e power 3x plus c2 into e power x, and particular integral is 2 into x into e power 3x. This is our complete solution or general solution of the given non-homogeneous equation. So here for the particular integral, based on the q of x value, we are having the different methods. So for the e power x, we can follow the method 1. So for the procedure of the particular integral methods, we can you can go through my videos for the particular integral methods, method 1, method 2 and method 3 and method 4. So then we can get the clarity about the particular integral problems and simultaneously about the non-homogeneous equation problems also. So this is the way to solve the given equation up to for the general solution of the given equation. But here they given one more. Here they given conditions also. So here what is the y value? Y value is actually, so what is the y value? C1 e power 3x C1 e power 3x plus C2 e power x plus 2x into e power 3x. This is the solution we got here. So here what is the condition they given in the problem? So y of 0 equal to minus 1, y dash of 0 equal to 3. Y of 0 equal to minus 1, y of 0 equal to minus 1 and y dash of 0 equal to 3 we are having. So by using these two conditions, we are going to get the values of C1 and C2. So first we are using y of 0 equal to minus 1. That means from this equation, we are going to get, so minus 1 equal to, in place of x equal to 0, so C1 e power 3 into 0 plus C2 e power 0 plus 2 into x value is 0 e power 3 into 0. This is 0 and here 1. So we are getting C1 plus C2 equal to minus 1. C1 plus C2 equal to minus 1. Next, what is the sixth condition? Y dash of 0 equal to 3. So that means I need y dash value. So from this equation 1, I am getting the differentiation here. Y dash equal to C1 e power 3x value into 3 plus C2 e power x into x value is 1 plus here u into v formula. So x into e power 3x into 3 plus e power 3x into x value is 1. So finally, what is the y dash value? 3 into C1 e power 3x plus C2 e power x plus 2 3s are 6 here. 6x into e power 3x plus 2 into e power 3x. So now I am using the condition y dash of 0. So y dash of 0 equal to 3 here. I am applying here 3 equal to 3C1 e power 0 is 1 plus C2 e power 0 is 1 plus here x value is 0 means this term is 0. Here 2 into e power 0 is 1. So finally I am getting here 3C1 plus C2 equal to 2. So already we are having the equation C1 plus C2 equal to minus 1. So we are going to solve these two equations to get the value here. So 3C1 plus C2 equal to 1. So when you are solving these two equations, we are getting C1 equal to 1 and C2 equal to minus 2. So here we got the arbitrary constant values. C1 value is 1, C2 equal to minus 2. We can replace in the equation. So finally, y equal to minus 2 into e power x plus 1 plus 2x into e power 3x. This is our final solution after replacing the constant values. This is the way to solve the given non-homogeneous differential equation with conditions. I hope you get the clarity about the homogeneous and non-homogeneous equations. And here for the more examples, we can refer these textbooks, Higher Engineering Mathematics written by B.S. Gravel and a textbook of Engineering Mathematics written by N.P. Bal and Manish Goyal and Higher Engineering Mathematics written by V.V. Ramana. So these are the textbooks you can refer for the more examples and to get the clarity about the remaining problems also. So here I hope you get the clarity about the homogeneous and non-homogeneous equations. So here we can learn some more problems in the coming videos. I hope you understand very well and you get the detailed information about the problems on linear differential equations. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.